All right, then came 6-4, which was the rhombuses, the rectangles, the squares. So it said first identify the parallelogram. If I have a parallelogram that has 4 congruent sides, this is a rhombus. And what's true about the angles in a rhombus? You know 2 things about what happens with them. Say again. The opposite angles are congruent because it's a parallelogram, right? But then what happens with a rhombus? What makes it even more specific? Yeah, what happens with the angles? Where the diagonals meet is 90 degrees, right? So all the angles on the inside are perpendicular, right? That's perpendicular, so those would be 90, which makes 390. And then these angles are always bisected. So that means if they're opposite are congruent and they're bisected, it means all 4 of these little parts are congruent. So if this one's 32, this one's 32, I know 2's 32. And then I've got a right triangle up here that I know 90 degrees, I know 32 degrees, add those, subtract them from 180, and that last remaining angle, that's a 58. It's 58 degrees. So diagonals in a rhombus are perpendicular and they bisect the opposite angles.
You do 58 minus 32.
No, so to get number 1,
Yeah.
I knew 2 because that one and this are congruent. Like I knew 2 was equal to this angle because they're bisected and opposites are congruent, right? So 2 is 32. I knew this was a right angle because where the diagonals meets perpendicular. So then I can either add up the 32 and the 90 and then subtract that from 180. Or if this is 90, then these 2 have to add up to 90. I can just do 90 minus 32. Either way, you get that 58 degrees. 22 is a rectangle because it is a parallelogram with right angles. In a rectangle, I know all 4 corners are a right angle, and I know the diagonals are congruent. So once you look at, probably the easiest one to find for me would be this one, because those 2 have to add up to 180. So I would do 180 minus 56, and I get 124, so that's here. Then in the top here or the side here, doesn't matter which one, I know that this has to be 90 degrees and 62 was given to you. So if I do 90 minus 62, I get 28, which is what angle 2 is. And then I've got a triangle here. So I added 56 and 28. I got 84, subtracted 84 from 180, and I got 96, which was that last angle inside there. Alyssa. Just like you did here. No. Only if it was a right angle and all 4 congruent sides would it be a square, but I would still just say that's a square. So you're coming up with the best, most specific answer. So if it's just 4 sides marked as congruent, rhombus, just right angles, rectangle, combination of both, square. Jordan. These 2 here, these 2 form a line, right? Like there's a line here. So these 2 angles form a line, and 56 was given to you. So I did 180 minus the 56. Then came a rectangle with diagonals. So what we know about a rectangle, again, is diagonals are congruent. If MO is 3x plus 2 and PN is 20, I set them equal to each other, solve, and I should get x equals 6. Remember diagonals. Diagonals in a rectangle, and we're going to get to it later, but in an isosceles trapezoid, those 2 are equal, and a square, because everything that's true about a rectangle would be true about a square. Then we went to trapezoids and kites. So in a trapezoid, with those first 2, if it's an isosceles trapezoid, we know that the angles that are next to each other, the base angles, okay, the 2 that like where the legs meet the base, these would be congruent. So 45 and 3 are equal. 3 would equal 45. And then these angles are supplementary because those are parallel lines. And then 1 and 2 are congruent. So I did 180 minus 45 to get 135 for angle 1. And then angle 1 and angle 2 are the same. Yep. Alyssa.
How did you get, how come 3 isn't 80 degrees?
You mean for number 34?
Or no, sorry.
So 34, they basically took that trapezoid, turned it on its side. The two that are equal are where the leg, which is the one that's congruent, where the leg meets the other side. That one is going to be congruent to that one. They should both appear to be acute or both appear to be obtuse. So this is kind of rotated, which is why it's hard. But look, because they should both be obtuse or both be acute. Like those both look acute. Those are the 80s. And then these two are both obtuse. Those are the 100s. Okay, then came a kite. In a kite, again, we're back to diagonals are perpendicular. So diagonals are perpendicular in a kite and in a rhombus. So if I look at 35, for example, these are all 90. Immediately, as soon as I know it's a kite, I know those are all 90, which means angle 1 is 90. Then it gave you this angle here is 65. So if I look at this triangle, this one was 90. This one's 65, add them up, I get 155, subtract it from 180. Did I do that wrong? This one's not right.
How come it's not like 360?
Because I'm using the triangle on the bottom. I'm not using the whole thing. If I added up the 4 big angles on the outside, it'd be 360, but I'm just talking about just that triangle. Right? So that's 155 and this is 25. And that would be angle 2. For 36, it's the same thing. I have the angles on the inside. These are all 90. And then I got given this angle here is 34. So if I add this triangle, if I add 34 to 90, I get 124. Subtract 124 from 180, and I get 56. That's going to be, oh, this should be 50. I don't know. It's 56 there at the top. And then this is 38. I have another triangle here. You could look at it 2 ways. If this is 38, this is 38. And then this is again 90. So if I did 90 plus 38, 128. Subtract that from 180. And that's 52. So this should be 52. Yeah, because I wrote that 56. Oh, that's right. This should be 52. I rewrote the wrong one. Alyssa.
So you only did 90 plus 94 because you're doing in each separate triangle? Like the first triangle when you're trying to find angle 1, you do 90 plus 94?
Correct. So I broke it down into different triangles. Like this one I used for the first one, this triangle here. That's the first one. So those 3 angles, the 56 was what was missing. The 90 and the 34, I knew I added those, subtracted them from 180 to get the 56. Then this triangle is the same as this triangle down here. So I took this 38, put it here. And then I used this 90, this 38, and subtracted it from 180 and got that angle too. (37) was talking about the mid segment. So it says the trapezoid has a base length of 6x minus 1 and 3. Its mid segment has a length of 5x minus 3. What's the value of x? So remember yesterday we talked about, a bunch of times, so we reminded yesterday that if I add the 2 bases and divide by 2, base 1 plus base 2 divided by 2, I get the mid segment. So I did base 1 as 3, base 2 is 6x minus 1. The order there doesn't matter. Divided by 2 equals 5x minus 3. To get rid of this 2, I multiplied by 2 on both sides. This went away. And then I distributed the 2 in here, and I got, this got canceled off. 2 plus 6x equals, distribute the 2 in, 10 minus 6. And then I subtracted the 6x from both sides, added the 6 to both sides, divided by 8, or divided by 4, and I got x equals 2. Alyssa.
How is it -3, and then how did you get 2 plus 6x?
So the -3 comes from here. That's your mid segment. How did I get 2 plus 6x? I took these and combined my like terms. So I did 3 minus 1, and it gives you 2.
Okay, so
The bottom 2, I multiplied on both sides, and it cancels it from the left. So it's gone from the left.
So the 3 on the bottom, you just added it to the 6 minus 1.
Right, so it was like this, 3 plus 6x minus 1 divided by 2, because that's base 1 plus base 2 divided by 2 equals 5x minus 3. That's how it started, right? So then I combine these like terms. 3 minus 2 is 2 plus 6x. Let's say it's still over 2 equals 5x minus 3. Then I'm dividing by 2. I want to get rid of it. I'm going to multiply by 2. This cancels, but I get 2 plus 6x equals, and that 2 is going to get distributed. 10x minus 6. So then I subtracted the 6x. I get 2 equals 4x minus 6. Added the 6. Oh, sorry. Adding 6 in my head. Add the 6. 8 equals, this is gone, 4x. And then divide by 4. And x equals 2. So it's base 1 plus base 2 divided by 2.
It yet are the 8 kids.
Okay, so how many sides does an octagon have?
8.
Easy. Sum of interior n minus 2 times 180. If it's an octagon, it's 8 minus 2 times 180. 6 times 180. So then 180 times 6 is 1,080. Then it says each interior. So this is the n minus 2 times 180 divided by n. We already found the n minus 2 times 180. It's still the same shape, right? So it's 1080 divided by the number of sides, which is 8. So then I do 1080 divided by 8. That's once. 3 times. 5 times. So it's 135 degrees. If it was a fraction at the end, you can leave it as a fraction. If it's a decimal and you feel comfortable with that, that's fine. What? 135, yep, because it terminated. Then comes sum of exterior. So what is the answer to that question? 360. I should, again, be able to beat you over the head with your own iPad if you don't get sum of exterior angle right. 360. No work. Okay? Each exterior is 360 divided by the number of sides. You're not going to get it wrong. You're going to get it right. So 360 divided by 8. Hang on, yeah. 32. 5. So each exterior is 45. All right, given A, B, C, D is a rhombus, find the measures of angles 1, 2, 3, and 4. So again, rhombus, all the sides are the same. The diagonals are perpendicular, which means this is 90, this is 90, this is 90, this is 90. Angle 1 is 90 degrees. You already know 1. Then the diagonals bisect the opposite angles. So each pair of angles that are next to each other are congruent.
Oh, so it's not like 40 is congruent to 4.
40 is congruent to 4 because it's opposite 2, right? So 2 is 4 because diagonals bisect the opposite angles. But then it's still a parallelogram, so opposite angles are still congruent, which means each of these parts are going to be congruent. So 4 is also 40. And then you look at this little triangle here.
90 minus 40.
Yup. and angle 3 is 50 degrees.
It looks.
That's it.
It seems like so much more work.
All right, given A, B, C, D is a rectangle, find the measure of angles 1, 2, 3, and 4. So these are rectangle, they're not perpendicular, right? So the diagonals are not perpendicular. But rectangles are, the angles in the corners are all 90. Okay? You have vertical angles in the rectangle, right? If this is 120, this is also 120. So angle 1's 120. You also have a linear pair here, and a linear pair adds up to 180. So if two angles form a line, they add up to 180. So if I just did 180 minus 120, I get 60 degrees. So angle 2 is 60 degrees. Now the other ones get a little bit trickier because we have to think about these triangles as isosceles triangles. Okay, if it's isosceles, then the angles opposite the two congruent sides, which if this is congruent to this, these are congruent. All three angles still have to add up to 180. So if I did 180 and I subtracted the 60 that's here, I'm going to get 120. Both of these angles have to add up to 120, and they are equal. So I just do 120 divided by 2. And this is 60, and this is 60. So 4 is 60. And then I want to do the same thing with the triangle at the top because that's where the other angle is. Okay, again, it's an isosceles. All the rectangles form isosceles triangles because their diagonals are congruent.
So it's also 60?
So it's not 60, but because this is 120, I would do 180 minus 120. That's 60, but that's the sum of these two angles. So I have to take the 60 and divide it by 2. So if I had just looked, like, just think about just that single triangle at the top, right? This is an isosceles triangle. And that says 120. Isosceles means two sides are the same, but the angles opposite them are also the same. So these two are congruent.
You did 2 divided by 60.
So I did 180 minus 120, and I got 60, but that's the sum of these angles. So I have to divide it by 2, and I'd get 30 and 30.
Wait, so you got 60 from doing 180 minus 20?
You mean angle 2, 60?
Yeah.
Yes, that's that one, though. Then ignore that, because now I'm just looking at just the top yellow triangle, right? Just the top yellow triangle is an isosceles triangle, right? It has two sides the same. This one's same as this. Right, but these two have to be the same. So in a rectangle, diagonals are congruent and cut in half, which means this is always going to equal this, right? Which means in a rectangle, the 4 small triangles are all isosceles. In an isosceles triangle, the two angles opposite the congruent sides are congruent. So if I take away the 120 from 180, 180 minus 120, that means I have 60 degrees left over divided between these two angles. And those are the same. So I take the 60 and divide it by 2, and I get 30 and 30. Does that make sense? So that, I mean, if you ignore this triangle, like this whole triangle, just ignore it and just look at one triangle at a time. If you have that angle, subtract it from 180, divide it by 2, you get the other angles. Only in a rectangle, though, because the rectangles have the congruent diagonals. So then angle 3 is 30. And then the other part for the rectangle is AC, which is one of the diagonals, and BD. So if you want to redraw this, you can. Okay. A, B, C, D. AC is one of the diagonals, and BD is the other. We just said that these would be congruent or equal. So I do 70 equals 2x plus 50.
Can you see the triangle above it?
Say again?
Is it okay if you just see the triangle above it? So I'm trying to like the same letters.
Is it okay if you do the triangle above it? You mean go This one is isosceles trapezoid, right? Isosceles trapezoid means base angles are congruent. Shh. Base angles are congruent, consecutives are supplementary, right? So 3 is going to equal 60. Right? And then these are supplementary. These are supplementary. These are congruent. So once you get 1 or 2, you don't need to do the other one. It's the same. So if I did 180 minus 60, I get 120. Angle 2 is 120. And angle 2 and 1 are the same. So that's also 120.
That's it.
Yep. And then the mid-segment, remember the mid-segment is the sum of the bases divided by 2. So if this is 32 and this is 40, then I add those two and then divide it by 2. So I'd get 72 divided by 2, 72 divided by 2